Okay.
Okay. Ah. Okay. It seems it's clear now. It's clear. How many people have joined? The still. Yeah?
I didn't say anything.
No, they are saying this. Okay. How many people have joined now? Nobody.
I sent it.
I'm going to send it. Please rejoin through this link so that we can move. Please we can move. We are sorry for the clarity and wish it has been fixed. Please, we don't know why we are having technical issue this time around. Yeah. Okay, let's continue. Since someone has joined, let's continue. Okay. Please, as I said you should listen to this word, metallic bond. It's a very important word, chemical bonding. Very important, very important, very important. It's very important. Uh, very important bond. I said, this is the force of attraction. Metallic the force of attraction is an electrostatic force. It's an electrostatic force between positively metal ion and delocalized, take note of this, delocalized sea of valence electron. Some people can call this delocalized electron, they can call it mobile electron. You can also call it mobile what? Electron. That is the force of attraction between positively metal ion and what? Mobile electron. You can call the localized electron mobile electron. Let me quickly like you can also say or the force of attraction. The force of attraction between positively metal ion and metal ions and mobile electron that hold metal in a lattice. That hold metal in a what? In a lattice. Take note. The localized C of valence electron can be called what? Mobile electrons. Take note. Take note of that. Please take note. Take note of that. Please, how many people have done? 3. Please take note of that. Hope that is clear now. Please take note. Then, let me ask you, this is a metal. Look at it, this is a metal. These are positively metal ion. The clarity is still the same. The clarity is still the same. Please, just let me. The clarity is still the same, but you can hear me. I will try and speak so that you can understand. I will try and speak so that you can understand. We don't know what is causing that. We don't know. Please, but you can hear me. Just know. This we have when you are positively metal ion and what? Electron. The force of attraction between the positively metal ion and the what? Electron. That force of attraction is known as what? Metallic bond. And metallic bond is an example of what? Electrostatic force. Metallic bond is an example of what? Electrostatic force. It's a force that occurs between positively metal ion and what? The localized C of valence electron or mobile electron. The localized C of valence electron means what? Mobile electron. The force of attraction, which is an electrostatic force, that force is known as what? Metallic bond. Take note. Right. Take note. Metallic bond is responsible. Metallic bond is responsible. Metallic bond is responsible. Please, I know that it's not clear, but please, you can hear me. From my explanation, you will know what I mean. You will know what I mean. Please, you will know what I mean from my explanation. Metallic bond is responsible for electrical conductivity. Number one, it's responsible for number one, electrical conductivity of metals. Metallic bond is responsible for electrical conductivity. It's responsible for electrical conductivity. Metallic bond is responsible for electrical conductivity of metal. It's responsible for electrical conductivity of metal. Number two, metallic bond is responsible for thermal conductivity of metal. Metallic bond is responsible for thermal conductivity of metal. Metallic bond is responsible for thermal conductivity of metal. For thermal conductivity of metal. That's number 3. Metallic bond is responsible for what? thermal conductivity of metal. Number 3. Metallic bond is responsible for malleability and ductility. Metallic bond is responsible for malleability and ductility of metal. Metallic bond is responsible for malleability and ductility of what? Metal. Metallic bond is responsible for malleability and ductility of what? Metal. What is the meaning of malleability? Malleability. What is malleability? Please, assignment. Go and take malleability and ductility. Ductility is when you can draw metal to be what? Thin wire. Then what is malleability? When you can hammer metal to form what? Flat what? Sheet. Malleability. When you hammer metal to get what? Flat what? Sheet. Like your can Coke now. Your can Coke, you can hammer it and turn it to a flat what? Sheet. Malleability. When you hammer metals and get to a flat sheet. Ductility. When you can draw wire to thin of, when you can draw metal to thin of wire. Like those cable wire, electrical cable wire you see on your pole. What is responsible for malleability and ductility of metal is what? Metallic what? Bond. If they ask you, what is responsible for malleability, ductility of a metal is what? Metallic bond. What is responsible for electrical conductivity of metal is what? Metallic bond. What is responsible for thermal conductivity of a metal? Metallic bond. Take note. Right. Metallic bond is also number 4. Metallic bond is also responsible for high melting and boiling point of metal. Metallic bond is also responsible for high melting and boiling point of metal. Metallic bond is also responsible for high boiling and melting point of metal. Metallic bond is also responsible for high melting and boiling point of what? Metal. Metallic bond is also responsible for high melting and boiling point of what? Metal. Metallic bond is also responsible for high melting and boiling point of what? Metal. Full stop. Take note of this. Take note of this. I will draw it to be big on the board, big, so that you can still see it clearly. I will draw periodic table of 1 to 20 elements, so that periodic table of what? Group 1, group 2, group 3 metal only. Look at this. Group 1, we have group 1 metal. I don't need hydrogen. Hydrogen is not a metal. I need the hydrogen. Lithium, sodium, potassium. Group 2 metals, beryllium, magnesium, calcium. Group 3 metal, boron, aluminium. Let me stop here. Group 1 metal, group 2 metal, group 3 metal. Hope you can see this. Take note of this. Let it be in your, write it down. Metallic bond, right now, metallic bond decreases across the period Let me see if this thing, okay, it's clear enough. You can still see what I drew on the board. You can still see what I drew on the board. Okay, what does it? I said metallic bond strength increases. Right. Metallic bond strength increases. Increases. Nothing. Metallic bond strength increases from left to right across the periodic table. Metallic bond strength increases from left to right, according to this table I have, from left toward right, from left to right, across the periodic table, across the periodic table. Metallic bond strength increases from left to right across the periodic table. That means if you are moving from left to right, please, those people online, if you are moving from left to right, let me see, from lithium to beryllium to boron, it increases. Sodium to magnesium to aluminium, it increases. Potassium to calcium, it increases. You are moving from here like this, it yeah, across the period.
But you said it decreases across the period.
Is that what I said?
Yes. The first one. That was wrong. You said metallic bond decreases across the period.
Please change it. I said metallic bond strength. Please, right, change it. Metallic bond strength. Metallic bond strength increases. Metallic bond strength increases. Metallic bond strength increases across the periodic table from left to right. Metallic bond strength increases across the periodic table from left toward right. Metallic bond strength increases across the periodic table from left toward right. Metallic bond strength increases across the periodic table from left toward right. That is, as you are moving from lithium to beryllium to boron, metallic bond strength increases. Do you understand? As you are moving from sodium to magnesium to aluminium, metallic bond strength also increases. As you are moving from potassium to calcium, metallic bond strength increases.
How about when you decrease?
You understand? Then second one, metallic bond strength decreases down the periodic table, down the group. Metallic bond strength decreases down the group. Metallic bond strength decreases down the group from top to bottom. Metallic bond strength decreases down the group from top toward bottom. Metallic bond strength decreases down the group from top toward bottom. Metallic bond strength decreases down the group from top toward bottom. That means, as you are coming down group 1, metallic bond strength decreases. That means metallic bond strength of lithium is greater than what? Sodium. It decreases. That of sodium is greater than what? Potassium. Yeah, metallic bond strength of beryllium is greater than what? That of magnesium is greater than what? Metallic bond strength of boron is greater than what? Aluminium. Do you understand? Metallic bond strength decreases. That is why if they ask you, option A, look at this, option A, you have sodium. Option B, those people online, listen, option A, you have sodium. Option B, you have magnesium. Option C, you have aluminium. Option D, you have potassium. If they ask you, which one of them is the hardest? Which metal is the hardest? Which metal is the hardest? Hardest is the hardest. Listen, as metallic bond, note, right? As metallic bond strength increases, the hardness of metal also increases. As metallic bond strength increases, hardness of metal also what? Increases. As metallic bond strength increases, hardness of metal also what? Increases. Take note of that. As metallic bond strength increases, hardness, the hardness of metal also what? Increases. Hardness of metal also what? Increases. Another point. As metallic bond strength increases, melting and boiling point of metal also increases. As metallic bond strength increases, melting and boiling point also what? Increases. As metallic bond strength of metal increases, as metallic bond strength of metal increases, melting and boiling point also what? Increases. And the video, please hope that you can hear what I'm saying. We've tried possible best to put on to do it properly, but we could not fix it. But you can hear me properly. Please. We are talking about what? The metallic bond strength. I said metallic bond strength increases across the period. As you are moving from left to right, metallic bond strength increases. Now, if you have the period 2, lithium, beryllium, boron, the one that has the highest metallic bond strength is what? Boron. If you have sodium, magnesium, aluminium, the highest metallic bond strength is what? Aluminium. But if you have, as you are moving down, metallic bond strength what? Decreases. If you have lithium, sodium, potassium, the highest metallic bond strength is what? Lithium. If you have beryllium, magnesium, calcium, the highest metallic bond strength is what? Beryllium. Do you understand? Then, and now have this question. Option A is sodium. Option B, magnesium. Option C, aluminium. Option D, potassium. They say which one of them is the hardest? The answer is what? Aluminium. Don't forget, I told you as metallic bond strength increases, what happened to the what? To the hardness of the metal is also what? Increases. Metallic bond strength increases like this, Abi. That is, this one has the highest metallic bond strength, isn't it? Therefore, which one we have within the hardest? Aluminium. As you are moving, metallic bond strength increases. The hardness will also what? Increase. Please, those people online, hope you can, I don't know. Please, we have tried to fix the situation. Please, if there's any question you want to ask those people online, please, you can drop it. Please. We don't know why the stuff is blood. I don't know. Hope that you understand. Please, metallic bond strength increases as you are going across the period from left to right. It increases, but it decreases as you are coming from top to bottom, down the group. It decreases. And the higher the metallic bond strength, the harder the metal. The higher the metallic bond strength, the harder the metal. The higher the metallic bond strength, the higher the melting and boiling point. If a metal has high metallic bond strength, the metal will be what? Hard. If they ask you between among lithium, sodium, potassium, among lithium, sodium, potassium, which one is the hardest? Lithium. Because as you are coming down, metallic bond strength will decreases. Among lithium, sodium, potassium, if they ask you which one is the hardest, the answer is for lithium. Why? Because the decrease higher melting point and melting point, and the hardest. Do you understand? Metallic bond strength determines the hardness and the boiling melting point of a metal. And metallic bond is responsible for conductivity, electrical conductivity, thermal conductivity, malleability, ductility, and what? Boiling and melting point of what? Metals. If they ask you, which of the following chemical bond is responsible for thermal conductivity of what? Metal? The answer is metallic bond. Which of the following bond is responsible for ductility of metal? Metallic bond. And what is metallic bond? It's an electrostatic force that occurs between what? Between positively metal ion and what? Delocalized what? C of valence electron or mobile electron. Take note. Take note of that. Please take note. Please. When we get to school, I will re-explain it. The video is something else. Please, I know, I understand. And take note of this. This one is in last year. Wahed. Note. Metallic bond is the only bond, right? Metallic bond is the only bond. Write it down. Metallic bond is the only bond. Is the only bond. Metallic bond is the only bond. It's not clear. Oh God. Metallic bond is the only bond that can occur in an atom. In an atom. In an atom. In one atom. In one atom. Metallic bond is the only bond that can occur in an atom. That means in one atom. Metallic bond is the only bond that can occur in an atom or one atom of a substance. Of a substance. It's the only bond that can do that. If they ask you. Look at this. When you have sodium, in sodium, what kind of bond occurs in sodium? Metallic bond. Because sodium is a metal. And how many atoms of sodium do we have? One. Na plus. This is not bond anymore. You understand? No, not covalent. This one is just tending to what? Undergo what? Electrovalent bond. But when you have an atom, in an atom, as in atom of a metal, it's only metallic bond that can occur in an atom of a substance, and that substance must be a metal. If you have, for example, iron, how many atoms of iron do we have? One. What bond occur here? Metallic bond. It's the only bond that can occur in an atom. If you have potassium, how many atoms of potassium do you have? What bond occurs in potassium? Metallic bond, because it's a metal. Take note, it's the only bond that can occur in an atom of a substance. And that substance is a metal. It's the only bond. No other bond. Take note. Take note. Take note. Take note. Take note of that. Take note of that. Let me re-explain. I said metallic bond strength increases as you are moving from left to right across the periodic table. It increases. That means as you are moving from here, metallic bond increases. This one, in this period, this one has the highest metallic bond strength. As you are moving from here to here, aluminum has the highest metallic bond strength. From potassium to calcium, calcium has the higher metallic bond strength. But as you are coming down, metallic bond strength what? Decreases. As you are coming down, metallic bond strength what? Decreases. And metallic bond strength determines the hardness of a metal. The higher the metallic bond strength, the harder the metal. And this they now ask you, among beryllium, magnesium, calcium, which one is the hardest? Beryllium. Among lithium, sodium, potassium, which one is the hardest? Potassium is very soft. It's soft. Lithium is harder than sodium. Sodium is harder than what? Potassium. Why? Because as you are coming down, metallic bond strength what? Decreases. Take note. Take note. Take note. Take note. Take note. Let us call it a day here because of the clarity of the video, so that before we go to physics we can find a solution. Please, we are sorry for the technical issue, but if you don't understand anything, please let me know. Just know metallic bond is simple. It's the force of what attraction that occurs between positively metal ion and what mobile electrons. Simple. And it's an electrostatic force. Even electrovalent bond is also an electrostatic force. Take note. Covalent bond is also an electrostatic force. If they ask you, take note of that. Let me give you that bonus. Electrovalent bond, covalent bond, they are electrostatic force also. They are electrostatic force also. Electrovalent bond, covalent bond, they are also what? Electrostatic what? Force. Take note. They are electrostatic force also. Take note of that. Please, at this moment, let us call it a word, a lovely day. I remain myself, Jama. Let us wait for physics. May God be with you. Hope the lecture is good.